So I think with and to all the students still joining and watching this later on.
Mm-hmm.
So basically, we are going to go through um, quickly through three topics. Um, but what I also thought is um, the first two topics is probably things that was covered in a lot of our other assignments, and I will actually schedule some time for us for tomorrow as well, for maybe going through the simple and compound interest questions, because I got a few in the chat on those questions. So let's see how far we get to tonight, and else I will also schedule some time for tomorrow as well.
Okay. Okay, no problem.
Cool.
That would be great.
Cool. I'm happy with that. So let's I think what going to cover in hopefully the first 30 minutes. And again, there will be three slots of 30 minutes. So I'll just record the others as well as people come in and out. Um, so
Okay, no problem.
so in topic two, basically the things that are looking at is around functions and how it are represented. So in the study guide, they talk about what is a function. They give you definitions around it, but nearly what we are looking at, and it's nearly to say, okay, but let me quickly. So we can get different types of functions, um, which nearly covers formulas. Um, in the function, there might be variables like a x and a y variable, and
Mm-hmm.
depending on what we need to work out, um, is the information that they can give us. So they can tell us we need to work out a function. They can tell us, okay, well, here is a function. You now need to draw a line with it, or need to draw it. Um, or they can give us a function with, say, a number of x variables so that we need to work out the y. So there's a lot of things that they can nearly ask us about the function, but I think what's more important is nearly the next step. So they, rather than to say here is a few things or here is, they would rather give you a function and tell you to calculate or to work out what is the y, or what is the x, or what is the answer. And I think that is very important. So what you will get is that they will give you a formula, and they might say, okay, your formula is something like that. So they actually give you the numbers, um, and then they will say, okay, but solve the y if x is a certain value. So that is definitely something that they will ask you. So if the question was solve y um, for x equal to, let's say, 7, then we will just replace the x by 7. So then your answer would have been, let's replace x by 7. So then 3 times 7 is 21, plus the 2. So which will give you 23. So if we were looking at this formula, they tell us the x is 7 and you need to calculate the y. That is how we would have then solved the form for the formula. So they can nearly ask you a few things. So they could have asked you, okay, but if y is 0, what is x? Or let's say if y is equal to 5, solve x. So they don't always need to have it that you substitute the x. They can also have it the other way around. So if y is 5, then the formula looks a bit different, and what we need to do becomes a bit different as well. So then we sit with the formula of 5 is equal to 3x plus 2. Then we need to take, or how I like to do it, I want to have all my x's on the one side, all my numbers without the x on the other side. So I need to take the 2 over. So to get rid of that, I basically need to minus 2 on both sides, because 2 minus 2 will give me, that will give me 0. So that can cancel out. What I do on the one side, I need to do on the other side. So 5 minus 2 is equal to 3. So 3 is equal to 3x. And then if I divide by both sides with 3, I get x on the one side, 3 divided by 3 on the other side, which is equal to 1. So they can really ask you from both sides to work out the formula, and I think that is very important. Linked to this, they could have then ask you to maybe draw that line on a graph. Let's quickly do that as well. Oof, I've got some problems with my so if y was equal to 5, let's say it's there, my x was 20, oh, my x was 1. My x was 1. If x was 7, my y would have been, okay, 23. So it's going to be up there somewhere. So your graph would have looked something like that. Also, that would be your point where it will go through the y-intercept. Okay, because where x is 0, y would have been 2. So roughly it would look something like that, but normally they would give you nicer data to work with to draw the diagram or to draw a graph. So this is nearly the things that they can ask you when you're working with functions, or when you're working with one function at a time. So what I've included in here is also some work around. So when we look at that linear function, what do we know about it? So I used for y equals mx plus c. So that's the one way you can write it. the other way that you can write it is y is equal to ax plus b. So there's just a few options of how you can write it, and that's why I just nearly added both, so that if I ask you or show something to you in the assignments, that you're not caught off guard because now suddenly they're using some different symbols, but it's actually the same thing. I think that is just, again, for me, important, that you know that there is two ways to represent a linear function. So in your study guide, they talk about, okay, so you've got the linear function, very similar to what we've now done on the previous slide. But let's look at this linear function, and first let's determine what the intercepts are and then draw the line. So when I have y equals to 2 minus 4x, the first thing that I would say, okay, they want me to determine the intercepts. Okay, cool. That's easy enough. So the one intercept is where y is equal to 0. So if y is equal to 0, the rest of it still follows. The same principle. Let's take the 4x over because I want to work with something that's positive. So I would have added on both sides 4x. So minus 4x plus 4x, it will be equal to 0. So now I have x is equal to 2 divided by 4, which is 1 over 2, which is a half. So if I had that line where y is equal to 0, my x is, let's say, a half. Okay, so let's then solve the other way around. So I need to solve for y where x is 0. So I replace the x with 0. That's actually cool. So that minus 4 times 0 is 0. So this is a very nice one. It is actually just y equal to 2. So where x is 0, y is equal to 2. And then if I needed to draw the line, the easiest then is just to link these 2 points with one another. And there is your 2 points with the line through it. So that nearly is a very quick illustration if you need to solve the intercepts or determine what the intercepts are, and when you need to draw the line. Just how we then represent this is we always have a data point as y and x. So, sorry, x and y. So when x is 0, we had y is equal to 2. That is there. And when x was a half, we had y as 0. So there is, if you need to write it in a point way as well. So that shows you the straight line. It shows you how to calculate the 2 points in there as well. Then the extra thing that comes with it is they can ask you, So in here, we knew that the slope was -4 because that m is the slope. Or if it was for a, that would have been the slope. So if it was given and they ask us what is the slope with this line, the slope would have been equal to -4. Okay, so that you can then read off the formula. But they can also give you 2 points, like in this instance, and then tell you, but what is the slope? For this, there is at least a formula. So the formula for that is the change in y divided by the change in x. And it doesn't matter if you say y2 minus y1, so that's the one change, divided by x2 minus x1. Okay, so let's first work that out. So y2, let's say that is y2, so it is 1 minus y1, 8, divided by x2, which is 4 minus 2. Okay, so that would have given us -7 over 4 plus 2, which would have given you 6. So that is, your answer is -706, but you could have also said, and that's why it doesn't matter which way around you do it, as long as you just make it consistent that you then use the same for the bottom as well. So you could have said your second point minus your first point, or you could have said your first point minus your second point. As long as you do it, what you do on the top, you do at the bottom as well. So let's look at it this way around. We would have had 8 minus 1. And at the bottom, we would have had -2 minus 4. So you would have had 7 over -6, which again gives you the same. So -7 over 6 is exactly the same as 7 over -6. So nearly the most important thing out of this is, as long as you keep what you do at the top the same as what you do at the bottom, and then it will pan out. So that is how you nearly work out the slope if they give you 2 points. So let's see, there's one more before we for the quadratic function. So this is still on topic 2, and then we can start the recording for the inner equations. But so on the quadratic functions, the big difference here is that now suddenly we have something to the power of 2. So if you look at the second part, is exactly the same as your normal linear function. It is basically the first part that makes it a quadratic function. And what is a view of the quadratic function. So you can definitely see with a quadratic function that but there's nearly a turning point, and that then dependent on what turning point is and how in on a diagram. But luckily, they tell us how we can work out the turning point. The intercept for y-axis is as the linear one, it's the c value. So
Your network is really, really bad. Did you start having
linear,
load
if you're
shedding?
doing what the c or goes with any with it will be your y-axis, and then to work out the set for x-axis and show you how to. The function is x squared. Okay, is a screen also bad?
Still here. I think it's load shedding.
Asandele is the voice recording bad, or is the screen sharing bad, or both?
I don't know if you can hear me.
Okay.
But I think that it's the load shedding that's affecting your network because your screen has also changed. Plus, your voice is breaking up.
I will just continue, and I will make the recordings available.
Okay, no problem.
Okay, so me thing is, let's work out the turning point.